All right, hello everyone. This is going to be another QA answer explanation. Today we will be going over Java set 3. So starting at number 1, a simple Java program is given below that prints whether an integer is in the range of 0, 5 is odd or even. So the question is, does the statement within the brackets of the if have any type? Now, if you remember from our previous QA reviews, we talked about how in Java, if statements are always will only accept a type Boolean within the evaluation. And if it's anything else, the compiler will start to complain. So for example, in this case, in this if statement, this will have to be a Boolean. So because of that, the answer will be C, yes, Boolean. It'll always evaluate to true or false. Number 2, find the output of the given program by selecting the correct answer from the given options. So we have all these Boolean declarations in num, 10, 15, bool out. So the first thing we're going to want to do is evaluate what the type, if this is true or false. So let's just copy that over. And again, like last time, when we evaluate these kind of things, we're going to want to just break it apart into pieces. So we got the expression right here. And another thing, and if you haven't seen this type of notation before, in Java, we are able to, what this is saying essentially is that Java will evaluate this left side of the question mark. And if this evaluates to true, then it'll execute whatever is in the first part of this two-part colon, right? And if this is false, it will execute this part. So this is another notation in Java that we can use to kind of simplify the way that we write code. And then behind the scenes, you can kind of think this as like a basic if else, like if this is true, it'll execute this, else execute this. So just a quick thing to keep in mind. But let's look at here. So let's start evaluating here. So we have num1 is not equal to num2, and that looks like it's true. 10 is not equal to 15. So let's make that true. Boolean var1 or not var2. So let's evaluate this. So var2 is false. So let's make that true. And this is true. So true or true is true. True and true is also true. So we have true, and then again, it's going to evaluate this left hand to determine which part of the code will be executed. And this is obviously true, right? This is only true left, so we're going to hit true. So now we know that var out is true. So let's go into the rest of the code. So we have while I is less than 3. If the var out, then we're going to print out if statement. So this is true. So we're going to enter the if statement and print out that print statement. So if statement printed. And now we're going to flip that variable. So now it's false. And increment I. So now I is 1. Now because it's false, we're not going to enter this. We're going to enter the else. So else statement printed. And now I is once again incremented. So now I equals 2. We're going to hit the else statement again and print out one more time else statement printed. I, so now 2 plus 1 is 3. So now because I is 3, it will not enter the while statement again. So it looks like our final answer is going to be A. All right, moving on. Number 3, for the given Boolean expression, T is true, F is false, tilde means not. Fill in the missing part so that the expression evaluates to true. All right, so once again, we're gonna just pretty much write in, we're gonna copy over this entire expression here. All right, so yeah, basically we want this entire thing to equal true. So let's keep that in mind. Not true or false. So let's just simplify this. So this is false or false. And false or false, that is false. True and not false. So not false is true. True and true is true. And now we have false and true, which is false. So it looks like we have false and missing part. And if you remember back in the question, we want this entire thing to be true, but we have false and. So if you remember from basic Boolean logic, in order for something to be true, we need both sides to be true or have a true or false. But because we have an and here, there is nothing here that could actually make this true. We could, if this is false, then false and false is false. If this is true, that's false and true, that's still false. So the answer here is actually going to be D, none of the above. For simplify the given Boolean expression using De Morgan's laws. The single quote symbol means complement negation of that Boolean variable. The plus sign is or, and if there is no gap between the two Boolean variables, it means an and operation between them. All right, so again, let's review exactly what De Morgan's law is. So De Morgan's law is essentially saying that if you have an expression such as A or, remember plus is or, A or B, and you have a not here, we can in a way kind of distribute the not here and flip, and at the same time flip the operator. So not A or B equals not A and not A and not B. So again, we kind of distribute the not to each variable and then we flip the sign. So we can also, this is also done reversibly too. So if we have A and B, A and B, we distribute the negative and flip the and to an or. So that will equal not A or not B. And this is really useful when we want to simplify expressions. So let's just, this is kind of our little key that we're going to use. This is what like De Morgan's law is. So let's start. All right, so let's start at the beginning here. So we have not A and B. And if you remember, I just wrote it up here. So we can simplify this by distributing the not and flipping the sign. So let's do that here. Let's distribute the A and then flip it. So this is going to be or A not or B not. All right, so let's bring this down. Now we're at here. So let's do the exact same thing. So we're gonna distribute this, and this is and, so we're gonna flip that to or. So the A not gets another not. So we're just gonna write that all out here. So A not, because this got distributed, or and then B not. Okay. And let's look at here. So this may look a little complicated at first, but another really important rule, and we will go over this in a bit on a later question. But essentially, if you look at the logic of this line right here, where we have an expression within this parentheses, as well as the exact same expression here, with just the negation, and then these are combined by and. So we're essentially saying some expression, the opposite, and some expression that is the true version. So if we can kind of simplify this out. This is essentially saying like X and not X. So, and just if you think about it logically, we're saying here that something is both true and false, and that is impossible, right? Nothing can be true and false at the same time. So this entire expression right here will actually just evaluate to false, because nothing can never be true and false. And another way to write that is just to false is also written as 0. All right, so let's keep simplifying this. We have a few double negatives here, so we can simplify by just canceling those out. Plus, so this will just be A and B. Plus, and then or false. All right, so the next step we can do is use the associative law, and we can kind of group the like variables together. So we have A naught plus A plus B naught plus B, 0. And now we can use the commutative law to rearrange the expression here. So we can use these parentheses here to, so we have A naught plus A plus B naught plus B. And this is something that we could have done a few lines ago, but if you notice that everything here is joined by ors, right? So we have all something or something or something or false. Now, what this essentially can do is this, we can completely take out this or false, because everything here is joined by ors, right? So something or false kind of just nullifies that whole part. So we can just take out the 0 here. So now we just have this. And now again, if you just look at the logic here, so we're saying something, if it's true, if A is true, so it can be true or false, right? And unlike up here, if you have something that is true and not true, that will never happen. So that will always be false. But in the flip case, when you combine these with an and, a variable is always either true or false. That is always 100% true. So what we can do is A or not A. We just simplify that to true, which is, in other words, we can just use 1. And same thing, B or not B. That will always be true, because the variable is always either true or false. So that is true or 1, 1 or 1. And that will equal 1. And again, there are more specific names for all this that we will be going over later, but just looking at it from the logical perspective, this is kind of the thought process we have. So number 4, the final answer looks like is B. All right, a Boolean expression along with its solution is given below. And again, they kind of repeat the same rules here. So you got the pluses, which is or, and then the spaces is and, the not is the negation. For each step in the solution, correctly identify the property of Boolean algebra that has been utilized to reach the current step in the solution by matching it with the correct property from the given list. The properties have been labeled in the solution with Roman numerals in parentheses at the end of each line. Okay, so this is a pretty big question, because we have to know what all these properties are. So over here, to save some time, I wrote down kind of a brief list explaining what each of these rules are. So let's just go over these real quick. So on the top, we have the dominance property, which is essentially saying, and this is something that we just kind of went over in the previous question, but if we have a variable and the opposite variable combined with an or, that's a pretty much it's always going to be true. If you think about it logically, something is always either true or false. So that is always going to be true. And then on the flip side of that, something is never both true and false. So that is, if it's something it's true and not true, then that'll always be false. The identity property says here, a term ORed with a false or and with a true will always equal that term. So if you look at a few examples here, if we have an expression here and then or false, that can kind of just negate out that false. And we saw an example of that in the previous question too. Because something that is or false, the expression will just kind of fall back into whatever this is. And then again, on the flip side of that, if you have something and true, then again, the validity of that statement will kind of always just rest on whatever that original statement is. So that is the identity. Next, we have the idempotence. Idempotence, it's a weird word here. States that combining a quantity with itself, either by logical addition or logical multiplication, will result in a logical sum or product that is equivalent. Now that's a lot there, but basically what it's saying is if we combine something with itself using or and, then that'll just equal the same. So true or true is always true. And again, false or false is false. And same thing for the ands. De Morgan's law, we talked about this earlier. Again, we can distribute out the negation and flip the sign to kind of simplify an expression. And then the same thing again for the and, we simplify it and flip it to an or. Absorption, so this one is saying that if you have two expressions combined by an and or, and if the operators are different, so in this case, this is a, if this is or, so this is and, or this is and right here, and this is or, then basically the validity of the statement will always rest on what the original statement was. So actually, yeah, this is and right here. There you go. So looks like if we have A or A and B, this will always simplify down to just A. And then on the flip side again, B or A and not B, the validity just kind of rests on whatever the outside statement is. So this doesn't matter anymore. It'll always rest on what this is. And last, we have the commutativity, long word there. Interchanging of the order of operands in a Boolean expression does not change its result. So we also, again, we saw an example of this earlier, but we can, if something is or, we can just rearrange it and it won't affect anything. And same goes with and. A and B equals B and A. So let's look at these steps here and try to identify what's happening. So we have this long expression here, and then we simplify this. So step one. So it looks like this first step right here is getting brought down. So the simplification looks like it's happening over here, this big second part here. So there is actually two steps happening here that we can take notice of. The first step is, if you remember back in the previous question, we said that if you have something that is an expression or the opposite of the expression, that will always be true. So in this case, we have A or B not. Or again, A or B. So if you look at here, you can kind of just group these together. So like if I wanted to simplify this, I could just declare a third one equals A plus B. And if we do that, we can more easily see that. So let's just start replacing this, right? So we have C C, and remember C equals A plus B. C, this reminds us of the last question here. So we have C or not C. And if you remember, that is always equal to true. A variable is always true or false. So this entire expression here will just always be true or 1. So the first step that happens here is looks like they keep this the same. And then this entire middle section, we deduce that this will always be true. So we can just have a 1. And then the last part is A naught plus B naught not. Okay. And if you look back to our notes here, the absorption law is basically saying that we can, let's get this out here. So remember, the absorption law is stating that if the operators are different and the term outside must also be inside. So in this case, for example, here, you can kind of think of it as like it'll absorb that, like the A will absorb all this and just make it A, right? It'll overtake it because the entire validity of the statement rests solely on this, and it kind of nullifies what this equals to. And this is kind of what's happening here, because since this is true, this will, because this is true and it's combined with and, this will essentially absorb that 1. And we can simplify it and it'll be the exact same expression. So right here, we apply that. So the first step here, step 1 will be absorption. So, I mean, just based off of the answer choices here, we can pretty much tell that the answer is going to be A, but let's just go down the rest of them just for practice. So going on step 2. We have this, and now it looks like they're applying De Morgan's law. So they're applying, they're distributing the not over, so not A, and then flipping the sign from a or into an and. So not A and not B, which is happening here. And then that is and again, looks like they're applying De Morgan's again. So they're bringing that in. So not A, which is A. And so flipping the or to an and then not B, which is B. So 2 is clearly an example of applying De Morgan's law. And let's look at number 3 here. So if you look at number 3, let's look back to our rules again. The commutativity rule is basically we are allowed to rearrange variables if they're combined with or and, right? And that's kind of what they're doing here. So it's not A, they're just bringing those together, and same thing with the B's. So third step is the commutativity. And then C, adependence, which is, remember, back up here. If you have something that is true or true, is true or true and true, that's also true. But in this case, it's kind of applying that, but in the flip side, it's saying if true and not true, which is always going to be false. I mean, again, B is true or B or not B, or B and not B, which is always going to be false as well. So we got false and false, which is false. So that's 0, but we can see that we applied the absorption first, De Morgan second, commutativity third, and then idempotence on the fourth. So this is a big lesson here because there's a lot of key terms, and if you didn't get it at first, that's okay, but really important to remember what all these does and kind of remember, if not you remember the rules, like the names of it, just remember the reason why things work out. It's really important to know why these laws exist. Just thinking of it logically, it's good to just go over all these. So let's move on to number 6 here. From the different code snippets given below, identify the ones which will execute correctly. Okay, so it looks like this is just a simple code review. So let's look at the first one here. int age equals 22. If age is greater than or equal to 18, we want to print out eligible, else not eligible. Everything looks fine to me. We have a Boolean expression here. We're printing it out. The else statement is not going to print. And remember, if the statement after the if or else is only one line, we can omit the curly brace. If this is 2 lines, then we're going to need it. So in this case, we're allowed to omit it. So this is looking fine. Looks like number 2 is the exact same thing, except in the else statement, we have else age less than 18. Else statements in Java do not have any parameters. It's always by itself. So this is going to be a compilation issue. So that's not good. Let's look at 3. So age is 22. So now this time, instead of else, we have else if. Else if is allowed to have a Boolean parameter. So that is fine. So it looks like number 3 is good. And then the last one here, else if age is greater than 18, which looks good. Else if age, that's fine. And again, looks like they're trying to add a parameter in the else, which is not something you do in Java. So 4 is not correct. So 1 and 3, or C, is the correct answer. Seven, from the options given below, identify which property holds true for flow of control using if-else statements in Java. Okay, so let's just see which ones are true. So A, the statements passed to if or else if as parameters was always evaluate to true or false, Boolean. Yep, true. We talked about this earlier. Or 0, 1 integer or byte for successful execution. Nope, that's not right. Remember, we talked about before, if statements only take in Booleans, nothing else, no integers, no bytes, no nothing. So X is not, or A is not true. If there's going to be only one statement within an if else, then curly braces are optional. And yep, we just looked at it earlier. In those if else statements, there's only one line, so we can omit the curly brace. So B is looking right. And let's see, lastly, the way to stop the execution from within an if else block of code is to use the break command. This is not true as well. The break command, as a refresher, is only used within a loop. So if you have like let's do an example, so like while X is less than 10, we can do something, right? And then we call break. Then this breaks out of that while loop. But this is not something you do in ifs. So looks like B is the answer for this. All right, being an object-oriented programming language, Java has extensive usage of classes and objects. For comparing whether 2 objects are equal or not, we can use the equals method or the double equals. For the given code, select the correct output. So we create new double objects, assigning equal values within those doubles, and then we're calling both the equals and then the equals equals. Now, this is a really important concept in Java, and let's just review a bit of what these actually mean. So in Java, as you know, we have classes, which are also called objects that we can create. And each of these objects has a reference in the memory. And the biggest differentiator on dot equals, so dot equals will compare if the values are equal. Okay. Dot equals will compare if the values are equal. Equals equals, and you may think it does the same thing, but equals equals compares the reference to the object, which in other words, the location of that object in memory. And that is the biggest differentiator between that. So this is compare the reference of the object. memory location. And this can be different because you can still have two objects that have the same values, but if they are stored in different areas of the JVM or in memory, then the equals equals will not necessarily be the same. And another big thing to keep in mind is in Java, when we declare the new keyword, that is essentially forcing a new place in memory to place that object. So in this case, we're creating two doubles and we're creating them as objects, right? We're calling the new capital D double, which is telling Java that we're going to be creating two variables, D1 and D2, and they're going to be their own separate object with their own place in memory. So equals D1 dot equals D2. So remember, dot equals, it compares the values of those objects. And what is the values? Looks like they're both 100.909. So calling dot equals, this will be true. This is true. Now we're going to do it again, but this time we're going to call the equals equals. And remember, we created two new doubles. Even if their values are the same, we created two new objects, and thus we're telling the Java virtual machine that we're going to make these two objects completely separate and basically we're going to store these in separate locations. So because of that, we're comparing using the equals equals, which is the memory location. This is not going to be true because the reference to these objects will not necessarily, or it will not be the same. So this is going to be false. So it looks like the answer will be A then. So true, it'll print out true, and then false afterwards. Number 9, for the given program, predict the output by selecting the correct option. So it looks like this is kind of on the same topic as what we discussed in the previous question, but now this time we're creating strings. So we're creating a new string. First one, it will just be a blank string. The second one will be a null string. Now, this is going to be another important thing to keep in mind is the Java virtual machine will only assign a location of the object if there is a value that is assigned. So in this case, even though str1 is a blank string, that is still technically a string. It's just an empty string. So it will place that somewhere in memory, but null is different in the fact that null is saying that we're not gonna even add a reference in memory yet because it's completely null. So the answer to 9 will actually be D, error, because it'll try to look at the reference to str2, and then it's going to see that it's null. There is no reference, and it'll complain. It'll throw a null pointer error. So yep, 9 will be D, error. Lastly, number 10, for the program or for the given program using a string object that has not been initialized, predict the output. So we have an example, and then we make a instance variable, declare a private static string str. And it looks like they just print out, or they try printing out str. And to understand this question is another pretty important concept on how instance variables in Java work. And that is that when declaring an instance variable, if there is no assigned value to that instance variable, Java will always automatically behind the scenes assign that value to null. So in this case, private static string str, behind the scenes, because we never initialize this to everything, Java just essentially is assigned this to null. So it looks like when we try to print that out, it'll just print out B, null. So Again, another thing is that because of the way that Java handles instance variables that are not declared, the default reference value is null. So it will not hit a null pointer. It will actually print out null, which is kind of Java's version of telling us that it has a reference to str, but the reference is just simply null. So the answer to this will be B. All right, so that'll conclude this Java Set 3. Remember, you can check us out on the website. We also have YouTube, which we will be regularly uploading videos like this. So if you miss it, or if you need to ever go back, you always have YouTube to go back and review and check. So, yep, thank you very much.